Hello and welcome. In this video, we're going to take a look at another application of algebra, setting up some equations and figuring out how to solve for x. But of course, setting up the problem is usually the most difficult part of these problems. We've already looked at some examples involving areas and distance, but now we're going to take a look at some other problems that have other applications. Let's look at some problems that involve mixing as well as distance, speed, and time. Now, first thing to know about mixing problems is how we calculate concentration. Concentration can be in terms of volume of a substance or maybe in terms of mass of a substance. Let's just say that the concentration is equal to some amount of a substance being put into a mixture divided by the total volume of that mixture. So C for concentration is equal to X for the amount of the substance divided by V, the volume of the mixture. And it is possible to rearrange this equation whenever we need to so that we can actually get concentration times volume is equal to the amount of the substance. Now, whenever you're doing problems involving mixing, we can add volumes and we can add amounts of substance, but adding concentrations doesn't make any sense. We can have something that has a 5% concentration added to something with 100% concentration, but we can never end up with 105% concentration. So it doesn't make any sense to add concentrations. We're only going to be setting up these problems so that we are adding or subtracting volumes and amounts. So keep that in mind. Here's an example of a problem that involves mixing. Okay, in this example, we want to know what amount of pure syrup has to be added to 30 liters of some solution containing 40% syrup in order to get a final solution that contains 50% syrup. Now, you could maybe draw a little picture of this. We've got a container of pure syrup. So if you wanted to illustrate that, pure would be 100% syrup. That would be its concentration. And then we're going to be adding that to 30 liters. We can denote that with a volume, and its concentration is 40%. And we want that to end up equaling a volume which contains 50% syrup. Now, we don't know all of the volumes, and certainly we can't do anything with 100% plus 40% equals 50%, because that doesn't make any sense. However, we can definitely start adding up volumes. Whatever volume we are adding to 30 liters will give us the total volume. So what might be very useful here is to think, well, the unknown here is what amount of pure syrup we want. We can denote that volume as X, and we can see that in the end we'll end up with 30 liters plus X more. And that does make an equation. X plus 30 equals 30 plus X. That is definitely something that does make sense. What might be very useful in this case, rather than just trying to force each equation, maybe start trying to put this all into sort of a table. And then from that table, we can look at the things that are getting put together, the sort of reagents of this, and then look at the products on the other side of the equal sign. Well, let's try putting this into a table format. Now, the first row in our table here, we might want to list our pure syrup, our given mixture, and our final mixture. And on our first row, we can put the information down. Pure is X in liters, mixture is 30 in liters, and the final mixture, we've just used a bit of an equation here to know that that should add up to 30 plus X. So on that row, it does make sense to add things up. Now, what about concentration? We could add that as another row. In the concentration row, pure syrup has a concentration of 100%. The mixture we started with has a concentration of 40%. And the final mixture, our goal is to get 50%. Now that row doesn't make any sense to add up. The first row is fine. We can say X plus 30, which gives us 30 plus X. But the next row, unfortunately, this is not a valid equation. 100% plus 40% certainly doesn't equal 50%. Well, what we need is actually one more equation that's going to give us a way to solve for X, and that would be looking at the formula for concentration. If we know volume, remember that this is V, and we know the concentration, C, then we can figure out X which is the amount of syrup in any one of these mixtures or pure containers. And remember, using the equation C times V equals X. So X times 100% is just going to be X. 30 liters times 40%, that means we have 12 liters of syrup in our 30-liter mixture. And in the end here, we want to have 30 plus X liters times 50% concentration. Now, once again, all of the amounts should be able to add up and create an equation. X amount of pure syrup plus 12 liters more of pure syrup should equal 30 plus X liters of 50% concentration syrup. And this is an equation right here that we can use to solve for X. Now this table, depending on the kind of question you're given, may have the unknown quantity in any one of these many places, especially on the top two rows there. But you can always try to follow this simple guide of putting volume, concentration, and amount, multiplying down, and adding the rows with volume and amount. And you should be able to come up with a sufficient equation to get the X variable isolated. So we'll try this out. Now the first thing to note here is that 50% is better written as a decimal as 0.5, and then we can distribute that into the brackets. X plus 12 must then equal 15 plus 0.5x. And remember, this is 1x on the left-hand side and 0.5x on the right-hand side, so we can subtract 0.5x from both sides. And this will give us 0.5x on the left-hand side of the equation. We can subtract 12 from both sides, and that leaves us with 3. And then, divided by 0.5 on both sides of the equation will leave us with 6. Now what is this answer? Well, remember, X is up here on the volume row. So we have just discovered how many liters of pure syrup we need. So we'll put this in units of liters. We need 6 liters of syrup. And if you would like to, then you can go ahead and even figure out how much is going to be combined total in the final mixture. 30 plus X would be 36 liters. So put this into context, we must add, and maybe write this out, we must add 6 liters of pure syrup. Now, as I mentioned, sometimes this is going to be a problem involving an unknown concentration, in which case you may have your unknown X being one of the second rows. But it still ends up working in the same sort of manner. Volume times concentration equals amount of the solute. Now, let's take a look at problems involving distance, rate, and time, or distance, speed, and time. There's another relationship here that's going to be very important. All right, for problems involving distance, rate, and time, it's useful to know the relationship that the rate, or the speed at which something is traveling, is equal to distance traveled divided by the time elapsed. And much like the formula for concentration, this can always be rearranged so that time is equal, and much like in the concentration formula example, this can always be arranged to get distance is equal to rate times time. And also similar to our concentration type of problem, we can always add multiple amounts of time together to get the total time, and we can add multiple bits of distance together to get total distance. But it doesn't make sense to add 2 rates or 2 speeds to each other to get a total speed. That's quite a different sort of concept. So let's take a look at an example where we might have distances, rates, and times and need to set up an equations. All right, in this example, it looks like it's quite a wordy problem. So we're going to try to turn as much of this paragraph into just some equations that we can work with. Now the first sentence here, a plane is going to fly 1,200 kilometers from Denver to Calgary and 700 kilometers from Calgary to Vancouver, in a total of 5 hours. So that's 5 hours of total flight time. Now, of course, with distance, we're allowed to add total distances together. So we know that it's traveled 1,900 kilometers. And we know that the 2 different flights needed to both be smaller than 5 hours added together, adding up to 5 hours. So of course, we can add distances and times. And now we get into a problem about the rate at which the plane is traveling. This is the speed now. Plane flies 50 kilometers an hour faster from Denver to Calgary than from Calgary to Vancouver. And we want to find out a speed. How fast is the plane traveling for both flights? All right, well, let's see if we can put this into some sort of table where we have distances and we have speeds, we have times all put separately, and then we can form equations out of distances and times. Let's see how we can do that. All right, I've set up a table here with 3 columns this time: distance, speed, and time. Now, remembering that we can add distances and add times, we could add another row here for total. So I've got Denver to Calgary, YYC, and I've got Calgary to Vancouver, YVR. And below that I have total. And remember, with speeds, it makes no sense to be adding them together. All right. Now, let's take a look at distance first. Distance from Denver to Calgary, we can plug in as 1,200. And remember, this is in kilometers. From Calgary to Vancouver, we have 700 kilometers. And if you wish to add those together, you can. We can get 1,900 kilometers. Whether or not any of this is useful, just keep in mind that at least you can add those, and we have an equation. Now, this equation doesn't have any unknowns in it, so this equation might not be super useful, but in other examples, you would be able to form an equation already. Now, what about speed? We know that the plane travels 50 kilometers an hour faster from Denver to Calgary than from Calgary to Vancouver. So which one of these is 50 kilometers an hour more? Well, Denver to Calgary is going to be adding 50 on top of whatever we call the speed from Calgary to Vancouver. We can call that anything we want. You could use S for speed, V for velocity, whatever you prefer, or even just R for rate. Now, don't add these together. This is just a relationship that we have a speed that's unknown and another speed that is unknown plus 50. All right, now what about time? Now, this is where we might have to use the relationship rate, distance, time, or rate times time equals distance. In this case, rearrange the equation as necessary. We might even need time is equal to distance divided by rate. Okay, so using that relationship, time from Denver to Calgary would be the distance from Denver to Calgary divided by the speed at which it was traveling, which we said was S plus 50. Now, for the flight from Calgary to Vancouver, we have a distance of 700 divided by a speed of S. Now, whatever those two times work out to be, the total time was 5 hours. We were given that information. And of course, we can add this and end up adding up to 5. So we'll end up being able to turn this into some sort of equation. This is going to be the equation with an unknown, but also we know what it's equal to. So we'll take that and write that out. 1,200 over S plus 50 equals plus 700 over S equals 5. Now, if we take a look at this equation, it may not look linear or quadratic. So how do we solve this? Well, we might be able to make it look linear or quadratic depending on what kind of preliminary algebra we can do. Seeing that we've got two rational expressions with a denominator of S plus 50 and S, we can find the lowest common denominator of S times S plus 50. Now, there are a couple options that we could use here. One option would be to get the common denominator on the left-hand side, add fractions, and then once we have them in a single fraction, cross multiply. But we could also get rid of all of the fractions ahead of time by taking this factor of S times S plus 50 and distributing it to the left and right-hand sides of the equation. Just make sure that it gets multiplied by every single term. Once we do that, we can multiply term by term and start canceling denominators. You can see that the S plus 50 cancels, and the s cancels, and we're left with a quadratic equation with no more rational expressions. Now, once you've gotten it to look more like a quadratic, make sure you get this into standard form. Try to get an as squared plus bs plus c equals 0, where s is going to be our variable. And you may try factoring that. If it doesn't factor, you can try the quadratic formula. This will be a good time, if you can, just to pause the video and try it out for yourself. And then I will jump to the solution here momentarily. Now, you may be surprised to find out that this does factor, but it's not exactly easy to find those two values. So you might just try the quadratic formula. And either way, you'll end up with two solutions. Either s is equal to 350 or s is equal to negative 20. But because we're talking about speed, we should be looking at this plane traveling forward, not backwards. It doesn't make any sense to have negative 20. Planes definitely travel a little bit faster than negative 20 kilometers an hour. It makes a lot more sense for this plane to be traveling at 350 kilometers per hour. Now, was that the speed from Denver to Calgary or from Calgary to Vancouver? Take a look back at this table so you don't have to read the question again, and we said that that was the speed s from Calgary to Vancouver. If we want to find the speed from Denver to Calgary, we need to add 50 to s. So, to answer the question, 350 kilometers per hour would be from Calgary to Vancouver, and we know that adding 50 to that, we have 400 kilometers from Denver to Calgary. And there we go. So, a little bit of a trickier question. I would say that most of the time when we're dealing with mixing problems or distance, rate, time kind of problems, it is very difficult to actually come up with the equation. That's where having a table strategy is helpful, and knowing what values you can turn into a sum. You can add distances, you can add times, you can add volumes, and you can add amounts. But you can't add speeds and have a meaningful result, and we can't add concentrations and have a meaningful result. Hopefully that helps you out with those strategies. Now, we'll see these again. We'll probably have to look through a few of these examples, and it does take some practice. I hope this has helped you get a little bit of information about it, and I will see you in the next video. Thanks for watching.